Fred. We've tried everything. I don't think anybody can hear us. Looks like we'll just have to wait for the fire department to get here.
I know. How embarrassing. We're gonna be stuck here for like ever. Will this thing ever move?
Well, it could move. Oh, if only there were some unbalanced force that could act upon this elevator to make it move again. Dearie, my memory has failed me. What is that called? Newton's rule?
Miss Tellway, are you talking about Newton's, like, first law?
Oh, thank you, Melinda. Such a smart girl.
Look, Miss Tellway, I know you, think you can teach me the laws of motion or whatever, but...
Oh, you like to learn the laws of motion. Do you? Well, I can never turn down a chance to teach. You're in luck. I was just planning my lessons for Newton's laws of motions.
Lessons? Sounds pointless.
Actually, it really isn't. For example, take seatbelts. Have you ever wondered how they work?
Not really.
Nonsense. First, you should know what inertia is. Inertia is an object's resistance to change. The amount of inertia an object has depends purely on the amount of mass that the object has.
So, if an object has a large mass, it will have a large inertia?
Precisely. Have you ever been on a roller coaster?
Of course. I go to the county fair every year with my friends.
Wonderful. Then you know that when you get to the top of the roller coaster, you feel like you're gonna fly out of your seat. That is because when the cart goes down, your body does not want to go with it. Thank goodness for safety bars.
Wow. Shouldn't gravity pull you down though?
A marvelous question, Miss Spoils. Technically, yes, and it does. However, the object, which in this situation is your body, will resist the pull of gravity for a short moment. If it weren't for your lap bar, the roller coaster would take off without you, leaving you to fall on your behind. Inertia works in mysterious ways.
Inertia must be an incredible force then. I can't believe I haven't heard about it until now.
Yes, it is indeed. So now you can hypothesize about what would happen if you did not wear a seatbelt. Wait till you hear what Newton's second law is. Do you have a guess?
Well, if you got into an accident, then you would go flying in the direction that you were traveling.
Very good. It is also important to know that greater force on an object means greater acceleration. This is also true if you flip the two around. Greater acceleration and mass make for more force. What do you think of wearing your seatbelt now?
It's a lot more important than I thought. You know, Miss Tuttlewhite, how you're teaching me right now isn't actually that boring.
And who knew that it could be fun in a cramped little elevator? Anyways, the equation to find force applied on an object is force equals mass times acceleration.
Math? Ew. Math is so not fun.
Well, maybe we can find a solution. Just remember this, friends matter a lot.
What does that have to do with math?
Let's see. It's an acronym. Now you'll never forget the triangle forms an F, M, and an A in that order.
That's easy. Why can't algebra be like that?
Now that is a question that both of us have yet to answer. So anyways, let's talk about gravity.
Gravity? That's easy. We learned that in third grade. It's the force that's pulling us down to Earth.
Right. More specifically, gravity is an attractive force between two objects which depends on mass and distance. I have a question for you. What effects does gravity have on projectile motion?
Projectile motion? I don't even know what that is.
Nonsense. Say, will you throw that marker to me?
Alright.
That is projectile motion. You are accustomed to throwing objects without much thought, and usually you can hit the mark. A projectile is anything shot or thrown through the air. It will follow a curved path due to gravity and inertia.
You're losing me.
A projectile simply has horizontal and vertical velocities.
Oh, like when one object is shot and one is drawn from the same height and they hit the ground at the same time. I totally saw that on Mythbusters.
Yes, they hit the ground because inertia and gravity are acting independently of each other.
So, to answer the question, gravity's effect on projectile motion is like everything that is acting on the object. That is the unbalanced force that keeps the object from moving for like ever.
Exactly, if you ignore friction. You're catching on so fast.
I still can't believe that I just learned about Newton's laws and gravity's effect on projectile motion. Okay, what's next?
Well, I'm sure you'd enjoy learning about centripetal force.
Yeah, no idea what that is.
Well, when you go around a turn, like in a car, centripetal force affects the car's motion, because without it, the car wouldn't make the turn. In this case, centripetal force could be friction, or the slightly banked roads that most ramps have.
Oh, that's why racetracks are banked. So centripetal force changes motion by making an object accelerate towards the same center of a circle.
What a marvelous way to phrase it.
Without centripetal force, an object like satellites would go flying off into space. OMG, I wouldn't get like any cell signals ever.
So, continuing with what we started about two concepts ago. Have you ever heard of Newton's third law?
I don't think so.
Maybe this will sound familiar. For every action force, there is an equal and opposite reaction force.
Oh yeah, I remember hearing something like that, but I was like, no way I'm listening to that, it sounds dumb. So then I just kind of tuned, I mean, yeah, but I've never quite, grasped the subject.
Sure you have. Don't you see? I'm jumping in the elevator, but it doesn't move.
Great observation, Miss Tuttlewhite, but I better just...
Don't let my antics confuse you. You see, I applied a force to the elevator by jumping, and the elevator pushes back. That's Newton's third law.
Oh, phew. I thought you were just getting claustrophobic. Well, cool. I see now. So if I push on a wall, then that's why it doesn't fall over. Why can't I push on something like a pencil over that?
Good question. That's because you are applying more force than the pencil can apply to you. However, if the friction between the pencil and desk is extremely high, like if there's glue, then it can apply that same force back on you. Or if you don't apply much force to the pencil, then it is able to apply that much force on you.
That's like genius. Got it.
Actually, there's one more thing. You remember inertia, right?
Yeah.
Well, there's something similar to that. It's called momentum. Momentum is basically inertia in motion.
You know, I think I've heard of that momentum thingy.
It's momentum, and good. Now, the difference here is that only moving objects have momentum.
That's not that different.
Now, momentum of an object can only change if its mass, velocity, or both change. Got it? The last part of momentum is the law of conservation of momentum. Let me demonstrate. Here's what I'm going to do. I will set one marker on the ground and slide the other one so that it hits the mark on the ground. Then you will tell me what you observed.
Well, the marker was hit and it like moved backwards.
Exactly. That's the law of conservation of momentum.
That's it. That when an object is not moving and it gets hit by a moving object, it will move?
Close, but not quite. When a moving object hits a stationary object, The moving object's momentum is transferred into the stationary object, which causes it to move backwards. Throughout this, the momentum does not change.
Wow, that's like so easy. Thanks, Miss Toddlehoyd, I actually learned some science. It was fun.
Anytime, Melinda.
Recording.
Oh, you're ready to go.
Okay.
No, I'm recording.
Oh, you are?
Yep.
Let's redo this whole page.
This whole page.
You want to just redo it from the top?
Yeah.
I can never turn down a chance to teach.
Just do the let it get all.
Yeah.
I'm just kidding. God, I'm so stupid. Body roll.
Body roll. Stop.
That is so funny.
I need to see it.
That's hilarious.
So everyone wants to wear the Penn State one.
Oh my gosh!
Yeah.
Oh,
I was just like, yeah. Oh gosh, I didn't realize I was. Yeah.
Join me. Join me. And you'll see on this magic carpet ride. Anyways, I feel sad.